Hello and welcome to our Data and Analytics Live event. My name is Dave and I'm a Data and Analytics Architect at Microsoft, and today we're going to be going through the keynote session for the day. And also remember, if you have any questions, feel free to post in the Q&A window as we go. So why is analytics and data important today? Well, quite simply, data is the lifeblood of organizations. Many business users inside of a company are turning to data to make decisions. Yet companies say that they are struggling to unlock that data from silos inside of their company. Not only that, data is growing exponentially. There is data being generated by IoT, there is data being generated by applications, and data being generated by SaaS applications as well. How do companies unlock that data? That is a big challenge that we're going to try and answer. At Microsoft, our mission is to empower everyone on the planet to do more. And to execute that mission, we view the world through the intelligent cloud and the intelligent edge. What do we mean by intelligent cloud and intelligent edge? Well, the intelligent edge is devices such as phones, IoT devices, drones, sensors on a farm, sensors in a building. The world is becoming increasingly connected. And that is what we mean by intelligent edge. But a lot of that data needs to be processed. It needs to be actioned. And that's where it happens in the cloud, the intelligent cloud. To give you an example, our campus in Redmond is a smart building. We have hundreds of thousands of sensors across the campus. So every time that you go into a room, the temperature will adjust and the lights will turn on. But managing all the data from those sensors is a big challenge. What if a sensor breaks? What if there are thousands of sensors that need action? To manage that, we use artificial intelligence to send a field agent to go and fix the most critical sensor if one goes down. And that is an example of how the intelligent cloud and intelligent edge work together. So given our view of intelligent cloud and intelligent edge, how are we at Microsoft driving innovation? Well, Microsoft Research is a big part of that innovation push. We have 8 labs across the globe and over 1,000 different researchers driving the innovation around data, AI, and analytics. For example, we are the first to use FGPAs in the data center. What is an FGPA? Well, it is a way of doing artificial intelligence and image processing that's over 10 times faster than doing it through a GPU. Not only can you use Azure to leverage FGPAs, but we have extended that technology down to the edge, so you can leverage it closer to where your data sits. We have done speech parity and used artificial intelligence so that machines can now read speech just as well as humans. The world has more than 6,500 languages, and we are making advancements in language processing and translation all the time. Microsoft Azure here, in fact, has reached human parity with English to Chinese and Chinese to English translation, and we can support over 60 different languages with our translation technology. We are now getting to the point where computers can start to understand the world around them. They can see, they can hear, and they can think about the objects in the real world. At Microsoft Research, we built comprehension technology that has beaten the best test that Stanford can offer. And of course, finally, there is computer vision. Computer vision is the ability to recognize objects in an image, in a video. At Microsoft, we have won many awards when it comes to computer vision. But this is not just technology that we at Microsoft want to keep for ourselves. We really believe in democratizing a lot of this technology. And it's not just for the data scientist or the statistician or the person with a mathematics degree. We want to enable every user of this technology to be able to maximize it, whether they are a business user, whether they're a developer, or whether they are the data scientist. So how do you become a data-driven organization and unlock the power of artificial intelligence? Well, it all begins with a strategy. There's 4 key points that we need to consider when implementing a data strategy around people and culture. The first is encouraging an environment of critical thinking. What does critical thinking mean? It means encouraging the ability to step out of your boundaries and step out of your personal biases and examine facts from a critical perspective. And there are design thinking workshops and other techniques that make it easier to do that. The second key component is instilling a culture of data centrism. What does that mean? That means every time you do a report or every decision that you make inside of your company or every time that you need to think about next steps, you instill data in that decision. You start looking for facts and reasons behind that and start asking for data instead of just sticking your finger up in the air and trying to make a decision. Third, democratize the data. Data shouldn't just be for the privileged few inside your company. It shouldn't be locked away in these data silos. It's really important to democratize data and make sure that it is a self-service model where people can access data when they need it. That does not mean, however, though, that people that shouldn't have permission to data get permission to everything. For example, I don't require permission over finance data, therefore I shouldn't have it. However, the data I need to do my job, I have access to, and I can get it in a self-service manner. Then, of course, there is continuous learning. And this is moving away from an attitude of knowing it all to learning it all. To become a data-driven company, you really need to adopt a mindset of learning and understanding instead of knowing. So what perspectives do we need to consider when designing our strategy? The first perspective is scope. What is going to be the scope of our strategy? What's going to be the purpose here? What are the things that we're going to include in the scope and exclude in the scope? The next, of course, is how are we going to collect data? What's our data collection strategy going to be? Which data are we going to consider to be master data? Which data are we going to discard? How long are we going to collect it, etc. The third, of course, is the architecture of our system. Are we going to be considering real-time data? Are we going to be considering batch data, or both? How is our system going to be architected in regards to that? The fourth perspective we need to consider is how we're going to generate insights and analysis. How are our teams going to dashboard? How are our teams going to explore data? How are they going to collaborate? Then the next perspective is around data governance. This is obviously a very important perspective. How are we going to manage requests for data, and who is the data steward and who is the owner of that data? Then, of course, next we have security. Security is all about who has access to what data, how are we going to encrypt that data, what are we going to do with personal identifiable information, and how are we going to secure our data in the event so it doesn't get breached. And our last perspective is our retention and our SLA of that data. We have different tiers of storage available to us that have different costs depending on how frequently we access that data and what SLAs are we going to have back to our business around the data that we provide to them. So we've put together our data strategy. Now there are three fundamental pillars of how we can do our organizational design. The first is we have a centralized model. Now what is a centralized model? It is where we have a team of data scientists that work on a centralized data lake. If the departments need data, then they'll send a request to that centralized team, and that centralized team will action that request. Some of the advantages of this system is it's very easy to measure the ROI on your data strategy. You have one team working together, so it's easy for them to share and learn off each other. And it's easier to execute your business strategy because it's executing against one team. However, there are some sort of significant disadvantages with this approach. One disadvantage is that innovation is slower. Your departments cannot easily go and innovate themselves. Another disadvantage of this is that you lose connection with your departments because everything is centralized. You don't have people out in the field understanding the concerns of the business users on a day-to-day basis. The second pillar is decentralized. And at Microsoft, this is the pillar that we tend to use because it is well suited for very large and complex organizations. In a decentralized model, your teams out in the field can access the data they need, they can quickly do the insights that they need, and they can innovate faster. However, it does have some challenges. You do end up with a lot of different data silos. You can have people doing duplication of effort and have duplication of tools. There also can be some change management challenges. And then, of course, we have a new emerging way of building your organizational design, and that is the Cloud Center of Excellence or the hybrid model. In this model, we try and balance the two different challenges against each other of the first two models. So in the COE model, we have a core team that sets the framework, sets the tools, and sets the design. They do mentoring of the organization, and then they try and implement those standards across that organization. There are some challenges, however, with this approach. Some of those challenges are you do need strong leadership of the COE because they need to enforce their policies and people need to follow it. So here's how our platform can help you execute against that strategy that we just talked about. So we have a solution for anyone. Remember, we talked about democratizing data and AI. So on the left, we have no-code, low-code solutions. That's driven through Power BI. Power BI is our platform where business users can quite quickly generate reports. For example, many of your finance team or many others inside of your company today may be generating reports out of Excel. And then when management wants to see that data, they'll copy and paste into a PowerPoint. However, with using Power BI, you can streamline that whole process so that business users inside of your company can quickly generate reports and filter that up to management in real time. Power BI is part of our Office 365 suite. And Power BI also can hook into what we call the common data model. The common data model is an attempt by Microsoft, SAP, and Adobe to standardize data across an organization. For example, think of a customer record inside of your company. You could have a customer record inside of your CRM, you could have a customer record inside another platform, and you could have a customer record inside your finance platform. That customer record could have different metadata in all of those platforms. And if you want to query it or build a report around that customer, it can be challenging because you have to then join all that data together and come up with your own common data model. We take away that hassle through our common data model by joining that data together. So when you data scientists or your business intelligence people inside of your company query that data, the data is clean and standardized. Then moving across to the right of the diagram, we have more complicated solutions for data engineers and data scientists. We have Azure Synapse. Now, Azure Synapse is a very exciting piece of technology, which is a data warehouse platform. But it's not just a data warehouse. We have the ability to do machine learning and analytics all in the one platform. We'll talk a little bit more about that later. We have partnered with Databricks to bring you Spark for your data scientists in a flexible and scalable manner. Now, Spark is quite complicated to use on-prem, and Spark can be quite complicated to use for those not familiar with it. However, Databricks makes Spark easy. And then we have our no-code, low-code solution, which is Data Factory. This allows you to move data from many, many different on-prem systems, whether it's SAP or Oracle, could be an FTP server or even a file share, without having to write code. Then once the data is moved into the cloud and moved into these data systems, we can easily move it through its data lifecycle and build a data pipeline. This is all powered by Azure Data Lake Store, which is a petabyte scale storage solution available in the cloud. So what makes us different? Well, we have 3 differentiators that you may find interesting. Our first key differentiator is what we call the edge. A lot of the cloud capability that we bring, we actually give to you to use in the edge, whether that be IoT Edge and our IoT services, or whether that is Azure Stack, which we'll talk about a little bit more later, bringing some of that advanced processing power down into your data center. We also have a very unique offering around Azure Sphere. You may have heard in the news a little while ago, Microsoft's first Linux distribution. Well, all of this data that we're generating and sending into the cloud needs to be secure. And Azure Sphere is a chipset and a technology that secures not only the traffic to the cloud, but secures the hardware of that device. It's something that's becoming very, very popular in smart building and smart city initiatives around the world. And then, of course, we have SQL Server 2019. SQL Server 2019 is bringing a lot of the power of that cloud big data estate down into your data center, because we understand that you may not be able to move all data into the cloud. So when it comes to Azure, we have a few differentiators. Azure is really where your IT and your developers work. So as mentioned before, we have Azure Databricks. Now, Azure Databricks is a very easy to use Spark platform, which is tightly integrated into Azure. We also have Azure Machine Learning. And Azure Machine Learning offers you low code, no code, and full code machine learning capabilities. So if you have citizen data scientists that understand machine learning but don't understand all the mathematics behind it, they can use Azure Machine Learning to rapidly start innovating. And a lot of our storage in Azure is built around what's called a strong consistency model. Think of an IoT solution. When you're moving data quickly through the environment, you need to be able to read data as soon as it's written to your storage. A lot of other offers only give you what's called eventual consistency. So that means that the data has to replicate before it can be read. For a fast-moving IoT solution, that's actually quite bad. What you want is strong consistency, so you can pick up that data and you can pick up that information and you can report on it as soon as it's been written. Our storage platforms offer strong consistency for that reason. Then, of course, a key differentiator that Microsoft has is our Office 365 suite. We have Power BI and Power Platform, which give you end-to-end experience across your entire data lifecycle. We have the common data model that we talked about before, and you're getting all this data, so what are you going to do with it? How are you going to action it? Well, that's where Dynamics and some of our other technology like the connected field service comes into play. So a big challenge that a lot of companies have when it comes to data inside of their organization is they generally have two systems. One is the data warehouse, quite common in a lot of companies today. That's where they'll have their data warehouse and maybe a lot of other different databases where their business intelligence and data scientists are working from. However, since the advent of Hadoop, a lot of companies now are also starting to expand into big data. So they'll have a data lake on-prem, which is usually HDFS, and will talk to a Hadoop system. And a lot of companies are struggling between these two systems. Do they invest more in the big data lake, or do they invest more in their data warehousing? Well, fortunately at Microsoft, we are joining these two problems together to solve both of them at once. And to do that, we use Azure Synapse. So Azure Synapse is a really exciting piece of technology from Microsoft. We're really reinventing the data warehouse. We've taken our SQL data warehouse technology, which is petabyte scale ability to do queries, and we've joined that with Spark. Not only that, there is now one place where you can ingest your data, you can process your data, you can run machine learning on that data, and then you can present that data for query purposes. So what's generally available today is the data warehouse and provision data warehouse, but what's coming in preview is the ability to do query on demand. What does that mean? Why is that important? Well, in a data warehouse, you may not want to store all of your data in the data warehouse itself. Why? Because it can be quite expensive. And if you're doing simple queries, for example, you're just querying a big transactional table where you're not joining a lot of data together, then you don't need that parallel compute capability. So we have the ability to have what's called an external table, and you can spin up a cluster on demand, you can query that data for very, very cheap, and then you can process that data without having to load it into the expensive data warehouse. And that is a feature that is coming this year. So let's go into a demo of how this looks. So welcome to the Azure Synapse demo. Now for this demo, we are using a fictional company with fictional data. However, there is a lot of sort of realistic data in here, as you can see. So the company that we are pretending to be here is a retailer called Worldwide Importers. Now, Worldwide Importers is a fictitious brick and mortar retailer based on a real world customer use case. They have hundreds of stores all over the world, as well as an online store. They sell a wide variety of consumer merchandise, including sunglasses, sports shoes, watches, wallets, books, and various products for home. So this demo shows how they modernize their data estate by combining data from disparate data sources using Azure Synapse Analytics. So this demo will drive home the potential business impact of having all of your data available in one place, which is Azure Synapse Analytics. So in our demo, our data engineer uses Synapse to ingest, transform, and load operational data, including sales, marketing, and finance data, unstructured and semi-structured data from IoT sensors in the stores, and social analytics data, and Twitter streaming data. All this data gets loaded into Azure Data Lake, and then pre-provisioned pools form the data into Synapse tables. So just to remind you, Worldwide Importers have hundreds of brick and mortar stores and an online store. So imagine a world where Worldwide Importers would like to create a dashboard where they can see clean, unified customer insight data alongside their structured enterprise of data. They would like to use historical campaign and customer analytics data to make decisions for the present. And even more exciting, they would like to use real-time streaming data from Twitter, as well as from IoT sensors in their brick and mortar locations. They would like to use data from the present moment to take decisions for the next moment. And then finally, they would like to use their data to predict the future, like product recommendations and number of visitors to their stores. So in that, we're going to be looking at using artificial intelligence. So what does Azure Synapse look like? Well, This is Azure Synapse, and it is our end-to-end analytics platform, which combines SQL data warehousing, big data analytics, and data integration into a single integrated environment. Synapse empowers users to gain quick access and insights across all of their data, enabling a whole new level of performance and scale that is unmatched in the industry. As you will see here in our workspace, Synapse brings all of our data into a single service. Synapse does not just remove the silos between people in the organization, but it also brings the data together. Now that we're in the workspace, let's begin with ingestion. In the Synapse world, data connections are called linked services. So in our data source section, we can see existing data connections, otherwise known as these linked services, and we can add new connections. As you can see here, we have a lot of connections already, and we can support many different kinds of data stores. In fact, we already are supporting, in this demo environment, Teradata, SAP, and Oracle. So what does it look like if we create a new connection? Well, we can go create a new data connection and look at all the different kinds of data sources that we can support. So not only your on-prem data sources are supported, but we support other cloud providers and we support web services as well. We even support things like Microsoft Access. Of course, if you have generic connections required, we support those too. So we can pull data from almost anything that supports a REST API or an ODBC connection. All right, so let's talk about the data pipelines related to our demo to ingest data. So let's close out of this and let's go to our Orchestrate Hub, which is where data engineers can build pipelines, orchestrate data movement, and deploy pipelines into production. Let's look at the pipelines that we have previously already set up. So Worldwide Importers has data stores in Teradata, Netezza, and Oracle appliances. They also have SAP HANA, and they would like to ingest semi-structured Twitter data. So Synapse has two types of pipeline experiences. There's code-free and code-first. Let's take a look at the code-free experience, and we'll go find our SAP pipeline. So here you can see our SAP pipeline. In this pipeline, we connect to SAP HANA data sources and we move the data into our data lake store. As you can see here, we have a data source which is set up in SAP HANA, and then we have a data sink, which is our dataset and data lake store. Now let's click on the mapping data flow, which will show us what activities are happening in this particular data flow. As you can see in this data flow, we're moving data from SAP to the data lake, and we're doing transformations along the way, and then we load it into Synapse. Synapse makes building these complex end-to-end pipelines a simple, intuitive, visual, and no-code experience. So what are we really doing here? So in the first activity, we are selecting data from the data lake staging area. In the second activity, we are filtering data from the last 5 years. In the third activity, we are deriving columns from a column order date. Then in the fourth activity, we are simply selecting the required columns from the table. In the fifth activity, we are creating an aggregated total sales grouped by year and month. Then in the sixth activity, we are aggregating the table into Azure Synapse. And then in the final activity over here, the seventh one, we are taking a parallel route by selecting all the remaining rows and writing that full table into Azure Synapse. In the data flow, there are a variety of simple no-code transformation options available. Let's take a look at some of these. So as you can see here, there are a lot of different common transformations that a data engineer is going to be using. Filters, sorting, joins, and unions, lookups, pivots, and windows. Now, let's go over to a pipeline where we have created a code-first experience to bring marketing data in from Teradata. So let's go back to our orchestrate and our pipelines. Now let's go to marketing database migration. As you can see, we are simulating the marketing campaign data to be coming in from Teradata. So here we have our Teradata marketing database. So in our copy activity, we can see here that our source system is the Teradata marketing database, and our sink here is the data lake store. Then of course we're doing some ETL and preparation on the data. So if we just click on this and click on settings, you can see that we're actually running a notebook. Let's have a look at this notebook. So now we've actually opened a Jupyter notebook. And in here you can see that we are using Python to do ETL in a code-first manner. Okay. To recap, so far we've looked at pipelines for finance data coming into SAP, or from SAP HANA, and marketing data coming in from Teradata. And of course, we can support many more data sources than just this out of the box. Okay, so now that we have all of this data in one place, let's go to our data lake store. Again, it's all part of the Synapse workspace. We have everything in one place. We have sales data, marketing data, finance data. We also have data from our CRM platform. And now that we have all this data, let's actually start querying some of it right here, right now. So let's go to data, and then let's have a look at our storage accounts here. If we expand this out, our data lake store here, we can see there is Twitter data coming in real time. Now these are Parquet files. Parquet files are highly compressed column store files that are optimized for performance. So let's run an on-demand query on these Parquet files. Now this is very easy. There's no need to provision any pools. There is no need to spin up any infrastructure or additional infrastructure. You simply select files, and then we right-click and we go New SQL Script. It'll automatically detect the format that we want to do, and then we can run this query. And then very quickly you can see that we have run a query on demand on a Parquet file. If we go back to our Twitter data here and we select another file, you can see that we can actually create an external table from this data. And what is an external table? An external table is a SQL table that you can query against, but the data doesn't get copied into the SQL database. This is very good for large fact tables or transactional tables that don't have a lot of joins. You don't need to move that data into your expensive SQL storage. You can keep it in your data lake store, in your HDFS compliant storage, and you can query it via the external table mechanism. Now, if we go back to our SQL script and we have a look at our query, inside of Synapse, it's also very easy for us to then go and visualize this data. This makes it great for data exploration purposes and data science and engineering activities. Now, I can also load selected data directly into Synapse tables as pre-provisioned tools. Now, this is part of the high performance MPP, which is multi-parallel processing data warehouse platform. And also do note that everything in here is, of course, a single source of truth. So let's expand, well, collapse our storage. Let's go into our databases here. Let's go into our MPP high performance database. Let's have a look at tables and wait for our tables to load. And it's very easy for me to switch between those on-demand queries and then querying my tables without having to go into different systems or different platforms. So let's see what the performance is like. Let's go into our Develop Hub. If you remember, we queried multiple Parquet files from Twitter. So let's move this data into an Azure Synapse table. So we'll go to Develop. Let's go to our SQL scripts. Let's go find external data to Synapse. Let us select the first query, which will create a table. Done. Now let's go to Azure Synapse and check if the Twitter table exists already. Now let's do the copy into command to copy the Parquet data. And now let's query that data. And there we go. We've just queried our Twitter data that has been moved into Azure Synapse. As easy as that. So let's go have a look at the performance of this system. If we go back to our Develop Hub and have a look at some of our scripts, let's go and run this command. We can see here that we have 30 billion rows of data. Let's do a complicated join on that data and let's see how quickly we can query this data. Now note here that we are selecting multiple different columns. We're doing some calculations here and we're joining data together based on these columns that we're selecting from multiple tables. This normally would be an expensive computation. Let's run that. In less than a second, over 30 billion rows of data, we have gone and queried that and joined that data together. And of course, it's very easy to visualize by clicking on the chart button here. Okay, so what about JSON? So JSON is a popular format used for data exchange, of course, especially when it comes to IoT. And Azure Synapse enables you to store JSON as well. So let's see the JSON extractor in action. We go back to our scripts. We go to our JSON extractor here. Notice that this is written in SQL. Now, let's select the query that we're going to run, which is our top query here, and run this. And there we go. So as you can see, we've directly queried JSON and we're viewing that with SQL-like code here in Azure Synapse. So what about the data scientist? So in the Data Hub, a data scientist can create their machine learning code and machine learning experiments using Python or Scala notebooks. So let's look how using Synapse, using the Apache Spark framework, we can bring big data and machine learning together with the data warehouse. Let's look at a notebook where we can use machine learning to create a product recommendation. So under here we have notebooks, and we're going to run this product recommendation notebook. As you can see, we're attached to a Spark pool and we're using PySpark. So of course the notebooks here in Synapse support PySpark, Spark.NET and Spark SQL. And you can see that here by the languages that are supported. Most Python packages come pre-installed in Synapse. Libraries also can be imported, and custom packages also can be installed. We can read from our databases and write to the tables in the databases, so the data can be used in other applications like Power BI and other websites. So let's scroll through this notebook and have a look at the output. So here's our import statements where we're importing libraries. Let's keep going, training the model, loading the model, product recommender, map products. So once this training model is loaded, we use it to recommend 5 products for every customer and use this recommended other products as well. We then store the results back in the database table for further consumption by other applications and users. So what about using automated machine learning? So in the Develop Hub, we can reuse or connect to an existing automatic machine learning workspace. So as you can see here, we're using the automatic machine learning libraries from Azure Machine Learning. So that experience is integrated between AutoML and Synapse as well. Okay, let's switch gears and move to Power BI. Okay, so let's click here on this report. So this decomposition tree shows the clicks on the Worldwide Importers website. The root node of this tree shows the numbers of visits to the website during a certain period. We can drill down to see the website visits by campaign and then the global region. So we can see visits here, we can see campaign, and we can actually get results by region. Let's just click on this, and again we can drill down there. Okay, so let's switch to the Q&A tab. Let's move this. Now this is a great feature where we can enter English language questions to create visualizations. Let's look at the profit by country. So let's go profit by country. And then let's choose actually by product category. And what we want is a tree map for visualization purposes. Product category as tree map. There. So now we can see the product category by country as a tree map. And we built that display very quickly, just using natural language that comes easy to us. Okay, let's create a few ad hoc Power BI reports right here within Synapse. These reports can be saved and shared with other users from within the Synapse workspace and shared at the enterprise level. So let's click here. So let's see how many empty rows of data we have. Sorry, not empty rows. Let's see how many rows of data we have here in this data set. So let's go to our all sales and customer ID. And what we want to do here is make this a number. There we go. So 30 billion rows of data. With these 30 billion rows, we're going to create another quick visualization. Let's see which products are performing well for our various campaigns. So let's go here, minimize this a little bit. Okay, let's go into customer ID, which we have, click on that. And then now let's join that with name. Hang on, I'm going to start that section again. All right, with these 30 billion rows, I'm going to create another quick visualization here in front of you. Go here, grab this. Then let's select name. Then let's select campaign. And then let's select a tree map. Let's make this a bit easier to read. And there we go. Over 30 billion rows of data without any performance slowdowns or impact. Okay, so I want to summarize everything for you. We showed you a lot. We have data coming in from our line of business applications. We also had operational and big data coming into Synapse, and all of this data was stored in one place inside of the data lake store. We looked at historical data helping us make decisions for the present, and then we also looked at using machine learning and artificial intelligence to build out recommendations. Then we built a Power BI dashboard on the fly over 30 billion rows of data without any performance issues or problems whatsoever. So thank you very much for the demo. So SQL Server 2019. You've just seen Synapse and you've seen some of the advanced technology in Synapse joining Spark and SQL together. SQL Server 2019 takes those same concepts and delivers that technology to you inside your data center. Again, we understand that not everything can go to the cloud for compliance reasons or other reasons, but we're democratizing that cloud technology and bringing it to you. SQL Server 2019 is not just SQL Server. It is the ability to run a big data cluster in your data center and combine that Spark and SQL together. SQL Server 2019 can also go and query other data sources. So it can remove those data silos inside of your organization. It can sit in front of Oracle, it can sit in front of SAP, it can sit in front of storage, and it becomes one place where your people can work. If you do want to learn more about SQL Server 2019 and it sounds interesting to you, we do have a SQL modernization live event that you can also check out. So we also have SQL Database Edge. Now, if you have an IoT solution and you're generating lots of data that you need to send to the cloud, maybe it's from a smart building, maybe it's from a manufacturing plant, then a lot of that data you may not want to process in the cloud. By the time it gets to the cloud, it may be junk data or it may be too late. SQL Database Edge allows you to run machine learning and processing inside of your building or inside of your remote site to filter out and process a lot of that data before it gets to the cloud. When it comes to image processing, however, let's say take an example. Shell, for an example, have gas stations around the world. They want to do hazard detection inside of these gas stations if somebody is smoking or somebody is doing something dangerous. They have CCTV footage that processes all of this video footage. Now, by the time you've sent this video footage up to the cloud from a remote site, potentially with a bad internet connection, and detected a hazard and sent that alert down to the gas station, it's too late. And that's where Azure Stack Edge comes into play. So like SQL Database Edge before it is good for processing sensor data, Azure Stack Edge is good for processing images. And in fact, this is exactly what Shell is doing. They have this technology in their gas station, processing images using machine learning at the gas station. And when a hazard is detected, somebody gets an alert straight away. So if you need that power of artificial intelligence image processing at a remote site, a mine site, a farm, or anywhere, this is where Azure Stack Edge comes into play. So let's talk about machine learning on Azure. So machine learning on Azure, we have a solution for almost everyone. At the top there, what you see is machine learning as a service. What that means is that Microsoft has trained a whole bunch of models already for you, so you can be a developer and you can use our machine learning efforts that we've already done. That is for things like image recognition, facial detection, speech recognition. However, that's only going to get you so far. These capabilities will be able to detect a face, but they won't know whose face. If you need to go deeper, for example, that's when you start using some of our lower level services. So when it comes to our lower level services, we are fully open source. That means that you can bring the tools and the frameworks that you're most familiar with, whether that is TensorFlow, whether that is PyTorch, or whatever other tools and processes. If you're a data scientist, we have Jupyter notebooks that are available for you to use. We have compute on demand, and of course you can use CPUs, GPUs, and FGPAs. So before we wrap up, one thing that's really important to Microsoft is building a better world. We really want to help use artificial intelligence to transform society and the world for better, whether that is building AI for disability, or whether that is using artificial intelligence to help farmers get a higher yield on their crop and tackle climate change, or using AI for humanitarian efforts such as food distribution. So how do we build a framework about ensuring that we deliver AI for good? Well, there's a few different principles and practices and tools that we can put in place to do that. For example, let's say that we want to make sure that we get biases out of our data, whether that is examining court data. We don't want to have biases in that data that punish particular people of particular incomes. Or whether we're doing hiring and we want to make sure that we pay people fair. It's important to have practices in place to recognize when there are biases in our data. Then, of course, we have our principles. What are our principles going to be around AI for good? What are the things that we're going to focus on? And then how we're going to use tools to recognize biases in data or potentially find when our AI is not being ethical. So in conclusion, we at Microsoft have the platform, tools and capabilities to really help you execute on your data strategy. And whether that be the business users that have no code or low code experience, all the way to the advanced capabilities that the data scientist requires. We have 27 years of research and innovation that we want to democratize and give that innovation to you to use. And most importantly, we want to partner with you to use AI for good to help make society a better place and solve some of the world's most critical problems. Thank you.
Hello everyone, Ben Sadeghi from Databricks, here to discuss how to put together a modern data warehouse the right way, along with a few other use cases using Azure Databricks and Azure Synapse. So during this discussion, please feel free to post your questions in the Q&A portal and we'll get to them at the end of the session. A bit of background about myself. I'm a solution architect with Databricks, formerly with Microsoft, a CSA there, so I'm quite familiar with the Azure platform. I specialize in data science projects and getting customers up and running with their AI initiatives. So first off, let's talk about what is Azure Databricks. As some of you might know, it's a joint engineering effort between Databricks and Microsoft engineers who have together been able to implement a fully managed, collaborative implementation of Apache Spark on Azure. This first-party Azure service now provides you with single-click setup, native integration with all the other Azure data services, integration with Azure Active Directory for enterprise-grade security, plus other features. A few benefits to mention here. In terms of productivity, with Azure Databricks, you can get your environment, your cluster up and running within a matter of minutes. You have access to a variety of different programming languages, Java, Scala, Python, and R, along with SQL, to really build your Spark applications. As I mentioned, there's enterprise-grade security, what you expect from Azure. And on top of that, you have other performance benefits like auto-scaling, which we'll discuss briefly in just a second. So just a recap of the unified data analytics platform that Databricks provides. Going bottom up here, we see that we're leveraging the Azure infrastructure for all the resources needed. On top of that, you have the Databricks runtime, which includes an optimized version of Apache Spark. The Databricks Delta, which provides you an open flat platform for saving your data in a much more reliable format. And of course, you get a variety of different ML frameworks all bundled in together within this Databricks runtime. The runtime itself is accessed via collaborative notebooks and production jobs that are readily available. Apart from Databricks itself, you also have the larger Azure Data Services ecosystem, which it integrates with. So starting on the bottom right, Azure Data Factory, you can now actually build your data pipelines with Data Factory, where you're calling Databricks jobs directly within the Data Factory UI. You have native integration with Power BI. There's a Spark connector for pushing down your queries from Power BI to Databricks. And deep integration with Azure Active Directory, where you can now define your users and their permissions to the underlying data source here, Azure Data Lake Storage, for example. And these permissions are then passed through Databricks onto the data source using just the Azure Active Directory's single sign-on capabilities. On the left side, you see the variety of different Azure data sources that are supported. Again, native connectors with each and every one of these. Synapse itself, some of you might remember that and still refer to it as Azure Data Warehouse, SQL Data Warehouse. Of course, it's much more than that now. You have larger scale, you have native, basically, integration and a UI for Data Factory and Power BI. So in itself, has become a much more well-rounded platform for unifying your analytics. So let's talk about the two together, Azure Databricks and Azure Synapse. So for these, I'll look at 3-4 common Spark use cases, which you could argue cover 90% of data-centric workloads. We'll take a quick look at large batch jobs, ETL jobs, SQL analytics, streaming jobs, and of course, machine learning workloads. Now, keep in mind this architecture here uses just a few components, right? Maybe 6-7 components, all of which are big data ready. So it doesn't matter whether you're passing through 10 megabytes or 10 terabytes of data through these pipelines, you're still using the same components and the same scripts. Now let's break it down. Let's look at the various paths for the different use cases. Batch data pipeline, this is perhaps the most common one, often referred to as the modern data warehouse approach, is a scenario where you have Azure Data Factory picking up the data that's required and copying and moving it over to your Azure Data Lake Storage. There comes the extraction piece. You now have Azure Databricks stand up, extract the relevant data, perform the transformations and aggregations that need to be done, and then load those aggregates into Azure Synapse to then be served and consumed by BI tools. Here now, this approach is effective in two aspects. One, it's very cost effective in that you're saving your raw data within an inexpensive storage facility like Azure Data Lake. And secondly, you're minimizing your data footprint within Azure Synapse, hence also another cost-effective measure. And the other benefit from this approach, the modern data warehouse approach, is that you stop any sort of SLA drift from taking place. So as your data volumes increase, you can also scale out the ETL engine here, namely Azure Databricks, to meet those growing volumes and still continue to maintain the same SLAs that were defined early on. Okay. Now we're going to add one more component here and open up this architecture to streaming jobs. Here we've added now a message queuing framework like Azure Event Hub, Azure IoT Hub, or Apache Kafka, which then queues the events. In this example, could be something like IoT events coming in real time. This stream is here forked onto the data lake for later historical analysis, but the live stream is fed into Azure Databricks for real-time event processing. Here you can leverage one of two Spark libraries for processing streams, namely Spark Streaming and the structured streaming libraries. And from then on, continue with any sort of data cleansing, data augmentation, data transformations that are needed to happen on your live stream. This stream can then be passed on to another message queuing framework if it needs to be consumed by another engine, or more typically is passed on to an operational DB like Azure Cosmos DB to then be served to applications. Thirdly, we'll talk about machine learning. Here now, again, as a standard approach to machine learning, you start off with extracting the relevant data from your data lake, doing any sort of feature engineering and model building, model training within Azure Databricks. Okay, so now you've built your model and you want to use it for scoring purposes. Three approaches to scoring. One is batch, the most common approach, where you're using Azure Databricks to take a look at the newly arrived data, pass it through this pre-built model, make your predictions, and carry on passing the predictions on to Azure Synapse or another operational DB for serving. Other approach would be to score your data in a streaming fashion. Here again, you can leverage the message queuing framework to fetch data from and use Azure Databricks again to basically score onto that stream using the model that we just defined earlier. Again, these results can be fed into Azure Synapse, Azure Cosmos DB for the consumption by other applications. Thirdly is scoring on data that's real-time but sporadic. In such scenarios, we would actually suggest to deploy your model as its own web service. Here you can leverage Azure Machine Learning Service to build a RESTful API and deploy such a web service onto an infrastructure like Azure Kubernetes Service. Last but not least is business analytics. Again, you typically want as part of your ETL pipeline to perform your transformations within Databricks. The aggregations are then loaded into Azure Synapse. And from then on, Azure Synapse is used for your reporting and feeding data onto your BI tools. So that's the scheduled path. The other path would be the interactive ad hoc approach, where you're coming in live and querying your data from Power BI in an interactive fashion. And in this case, the queries from Power BI are pushed down to Azure Databricks, compute is done over there, and the resulting data set is fed back to Power BI for visualization. So I hope that this has been useful and in seeing how Azure Databricks and Azure Synapse work better together in a variety of different use cases. In terms of next steps, do look at the most relevant use case for your business. You can have a chat with the Databricks team to make sure that such deployments meet your security standards, and ultimately we can work together to co-develop and take your use case into production. Thank you very much for joining this session. Please post your questions in the Q&A portal. We'll get to them immediately. And please follow me on LinkedIn, Twitter, and GitHub under the Ben Sadeghi handle. Thanks again.
Hi, welcome to the Microsoft Data and Analytics live event. My name is Rangarajan Vasudevan, and I'm the founder CEO of the data team. And in today's talk, I'm going to give a view of what AI looks like from the trenches. And these are customer case studies we've seen implemented in the real life on Azure Cloud. And we'll give you business benefits. We'll also give you best practices and learnings. Throughout this session, the chat window is going to be open for you to post questions. And experts from all of our teams will be looking at it and answering them. We'll also have a dedicated session for questions just after my session is done. You can also use that time to post additional questions. So let's start with a formal introduction about us. At the data team, we specialize in building AI solutions for large-scale enterprises. These are cloud-native solutions engineered to bring business benefit in production, not just be piloted as AI case studies. What we will talk about as we progress in today's talk is 3 steps as enterprises embark on this journey. The first step is there is no AI without data. So how do you even get to govern data onto the cloud and have that be the source of trusted insights? That is the first part of my talk. The second part of my talk is focusing purely on customer analytics as it pertains to data from customers of clients. And the third part of the talk is other AI and ML applications, which are very interesting and sophisticated, but also at the same time bringing direct business benefit by sheer application of the AI technologies in real life. So let's start with the first problem statement, which is there is no AI without governed data. And governed is a very key word in this space because without governance, we're looking at potentially insights that could go wrong. So governed data definitely implies trusted insights. So how do we get to governed data? The typical problem statement that we've seen across multiple different enterprise implementations is the fact that there are various sources of data, and these correspond to legacy systems. And some of these legacy systems have been designed with monolithic architectures. These architectures are not really conducive for extraction or sharing of data in the first place. And what ends up happening is quality, as a result, suffers. So whenever quality suffers, we get to see that the data is not trustworthy anymore, and the business stops believing in the data that's actually coming in. The second part of the problem statement that we see is that the technology is constantly evolving with newer and more novel capabilities. So oftentimes, architectures which are designed for traditional ways of processing data are not really conducive to take the best benefit from the newer cloud technologies. So that becomes a significant challenge. The third part of the challenge is the fact that the cost model ironically makes it a case of deferring some of the best practices. So what we see here is because of the pay-as-you-go model that cloud is popularized, invariably enterprises have started to dump a lot of data on top of the cloud and then figure out aspects like governance at a later point in time. In our view, that works great if you're an internet company, if you're a digital company without any governance or regulation. But for most non-internet companies, which are predominantly the rest of the enterprise segment, this becomes a completely bad principle to work on top of. So definitely get governance in. And in fact, the best place to start with governance is right at the source system. And extraction of the data from that source system onwards has to have mechanisms which capture where the data came from, what's the lineage of that data, and what kind of quality the data has, and use those metadata that's captured in order to drive the insights which are trustworthy. So towards this, we've already built an entire solution called as Cadence Defend. And this is a turnkey solution built on top of the Azure cloud. In fact, it uses technologies like Databricks already. So what Defend does is to provide a managed solution for ingesting and managing data at very large scale on Azure cloud. And additionally, this allows a lot of the problem statements that we spoke about with respect to governance, with respect to having warehousing style best practices, and also have data be trustworthy, all of these natively taken care of. So with Defend, as an enterprise who's brand new to a cloud data platform, you could go live in 6 weeks' time. That's as little effort and time that it takes for you to actually be up and running. The best part about getting the data ingested through Defend is that the data in the platform then immediately becomes usable for any kind of downstream analytics. And there is always this guarantee that as and when you're interested in exploring how the data came about, you could always look back and see where the data sources are, how was the data getting processed, and what the lineage is, and also build governance around securing accesses to this data. And all of this is from the perspective of just operating on the Azure cloud directly. You don't have to look at multiple different types of interfaces and end up having additional layers of complexity, which is the case with additional competitive solutions. So if you look at the specific layers of capabilities, Defend is already built for the modern cloud. In fact, it's built using Apache Spark, runs on top of Azure Databricks so that it's superbly scalable. It scales all the way from smaller sets of files, large numbers of those, through to very large files which are being produced by large businesses which are operating at internet scale. So up and down the stack with respect to the structure of the data is also supported natively. So if we're talking about unstructured, multi-structured, XML, JSON, and the likes, apart from the relational sources. From a perspective of governance, we're looking at lineage being captured natively. Lineage is usually of two types. One is data, the other is process. Data lineage is extremely important for regulatory reasons. Process lineage, as it turns out, is also extremely crucial in order to have the insights that come out of it to be trustworthy. What I mean by that is it becomes necessary for a downstream consumer of the data, it could be the data science team or the business reporting team, to actually understand what process produced this data in the first place, and when was this process run, and what are the chains of different dependencies for that particular process when it actually produced this particular outcome. So all of that is actually natively supported. We have best practices like keeping a warehouse style copy of the data always on. So specifically what we mean by that is there is actually a complete snapshot of the source system, which is built natively as part of the entire processing that Defend does. And moreover, this is configurable. So the periodicity, the frequency, the refresh of the data layers is something that's completely up to you, the enterprise, to configure. We have seen clients go daily snapshots, as an example, all the way down to intraday, near real-time snapshots of the data. So all of this is natively supported. And the best part is this just seamlessly hands off into a warehousing solution like Azure SQL Warehouse. So this makes it extremely tight from a perspective of coupling with your favorite task services. So on a typical installation, we're looking at Defend using a few different components. So just to walk you through the logical architecture, various forms of source extraction you see on the left side of the screen. So these are classical databases, potentially as sources, but additionally, they could be API endpoints, they could be file systems, they could also be message buses, enterprise-wide message buses, or SOA architectures, like service-oriented architectures as well. So those are typically the sources of data. Note that not all those sources are actually going to be able to support real-time processing. Some of those are much better than others at being able to support real-time. Defend works on top of any of these types of sources, gets the data into the landing zone. That's a logical layer, which is meant to provide long-time archival of raw data. And from that landing zone onwards, it actually keeps track of lineage and does the processing as well. So for the processing layers, it uses Azure Databricks. In fact, it heavily leverages the auto-scaling capability of Databricks, and that's how we're able to get massive flexibility in terms of scale. We also have the governance enforced on the snapshot zone, which is the zone that's responsible for ensuring that data warehouse style best practices are actually produced natively as part of the defend output. So much so that the data that's actually stored in the snapshot zone could be directly consumed by any number of native PaaS services on top of Azure, be it for data science like Azure Machine Learning, or even the Databricks notebooks themselves. Or you could actually have your own custom coding that uses Spark and other forms of serverless infrastructure like Azure Functions. You could also deploy AI algorithms on top of it, starting all the way from cognitive services, all the way through the custom vision if you build up your own deep learning network as an example. And of course, you could use Azure Data Factory itself as a way to take this data forward and make it available for downstream data consumers in a way that's automated. And finally, we have, of course, the visualization capabilities of Power BI that's natively pluggable into this layer. Also, from an architecture perspective, we have catered to the need of having specialized areas for storing this data, additionally for instance, downstream consumption. So the world of open source databases, Elasticsearch, MongoDB, Postgres, all of those are supported as native specialized storage options on top of Azure. We also have Cosmos as a NoSQL option, which is globally scalable, always available. That's also supported as one of the target destinations from snapshot zone data. And of course, we spoke about Azure SQL Warehouse as, of course, a natural offering here. So let's take a look at a customer case study. So this is an example of a very large fashion e-commerce company, Asia-based. And here, the problem statement had multiple different parts to it. The first part was that the customer really wanted a stable, real-time operational platform for all of their real-time analytics needs. So the kind of analytics we're talking about are the likes that internet-born companies really favor. So these analytics drive the business decision-making. Like, for instance, what brand of clothing do I need to put on the inventory on my website for the next 1 week? How do I plan my sales season for the next quarter? So those are all examples of questions that get asked. Additionally, the business also looks at these numbers on a real-time basis to understand the latest movements in traffic, the latest movements of goods themselves, the preferences to certain brands and such. So the analytics themselves have to scale at different frequencies. What I mean by that is the fashion portal runs business as usual, but it also runs seasonal sales. And these seasonal sale events are multi-day format sale events. And during that particular seasonal sale, there is enormous amount of traffic that gets driven to the website and also to the mobile application itself. And so much so, we're seeing about close to 15 to 20x the scale in terms of traffic volume. And that kind of elasticity is a significant load on top of their existing systems. And they were actually with another competing cloud platform provider. So they were looking at options for engineering this from a stack perspective on top of Azure. And that's where we came in. And we not only helped them in migrate this entire piece of data and workload and the analytics pipeline, we additionally contributed more in terms of making the engineering pipeline stable and also having the data be ingested in a way that's governed. And thirdly, we also brought about automation benefits. And these were with respect to managing these resources as an application end-to-end. So invariably, what happens if you look at PaaS services is that the PaaS services by themselves are extremely good at managing their guarantees. But from an application standpoint, you'll have to think about properties like elasticity and scaling end-to-end application entry points all the way to the exit of the application. So that's something that we help them out with using the native properties of the the pass guarantees themselves, right? So long story short, we've got the migration done successfully. The data size volume that we're talking about is more than a petabyte of data. It's got one of the world's largest implementations of Azure Warehouse as well. Additionally, the real-time analytics pipeline, we could prove that not only we were able to get that in onto Azure using the likes of Kafka as the message bus, Spark Databricks as the processing layer, and Azure SQL Warehouse as the target destination for the warehouse data. Not only was this pipeline able to run on a BAU mode, but also this pipeline was actually able to scale to meet their seasonal sale requirements of elasticity of up to 20x the volume. So all of this was done seamlessly using automation of native application and PaaS service components. And this was achieved in a very quick amount of time. And that's something that the customer, in fact, was extremely happy about, and they did a joint case study with Microsoft as well. So that's the example I wanted to leave you with respect to getting the data in a manner that's governed for downstream insight discovery purposes. Let's move on to the next topic. This is around customer analytics. And this is a favorite topic of ours because we spend a lot of time talking to our enterprises about getting intelligence from customer data, because invariably most enterprises struggle with this problem statement. Now, the reason for why they struggle with it is a combination of the fact that skill sets are extremely rare. These are skill sets of data science applied at very large scale, the scale of internet companies or scale of very large financial institutions or telecom companies, which deal with so much mass of customer data. So building a team which is actually extremely skilled takes a lot of effort and takes a lot of money. And before you know it, you've got your favorite data scientist leaving you as an enterprise and joining the next VC-funded startup. So that becomes like a practical problem that you'll have to face if you're a team owner or a data science manager. So a 5-member team costs anywhere from like $400,000 to $500,000 on a yearly basis in terms of just the team cost by itself, setting aside the time it takes to actually build that team in the first place. Secondly, we've seen that the solution approach that customers typically take is to build a data lake where they get all kinds of data in and then talk about customer intelligence or solve for problems related to the customer initiatives. So, and we've seen that this kind of an approach doesn't really work because the data lake initiative itself ends up failing to deliver business outcomes in a way that's timely. So the problem statement then becomes one of, can I get to intelligence about the customer in a manner that allows me to scale to my entire customer base? So then what the enterprise ends up doing is they compromise on this requirement and they start to focus only on those customers who give them a lot of value or a lot of spend a lot of money. Or it could be the high net worth individuals as an example, or the high lifetime value customers. So they end up compromising on the fact that they're not able to cater to the entire customer base. They don't have that kind of big data skill sets, and they shrink it down in terms of requirement, and therefore the business benefit doesn't become commensurately as much as what they had hoped for. So the way we solve it is by using our solution, which is Cadence.ai. It's an automated customer intelligence solution built on top of Microsoft Azure, and it provides 3 fundamental capabilities. The first is it serves as what's called as a customer data platform, meaning it serves as a layer which allows you to integrate various forms of customer data, be it transactions, be it spends, payments, any kind of monetary kind of transaction. It could also be interaction data. These are customers interacting with you through various channels that you provide, through the mobile phone as an example, through the website, in-store, physically present with your partners, and the likes. Or it could also be second-party data, third-party data that add value and flavor on top of your customer data itself that you're collecting as a first party. So being able to bring all of that data in its entirety, right, at its volume with the velocity that your enterprise really functions at, and bringing it all together in real time is the core capability that kicks off a Cadence pipeline. The second is once the data is all available, and as and when the data is available, meaning in real time, there are AI algorithms that are operating behind the scenes to automatically mine interests from this data. And these AI algorithms are white boxed AI algorithms, meaning that as a data science unit, you could also look to add your own algorithms. You could look to add your own pipelines on top of it. And these are also configurable in the sense that you could parameterize them. You could bring in your own flavors of data pre-processing or data preparation using the Azure capabilities. All of these are available as part of the second feature set. Additionally, the platform also provides the ability for you to keep track of what kinds of algorithms are running behind the scenes. How do you benchmark them in terms of accuracy, and bringing your own versions of these algorithms using what's called as machine learning ops or ML ops. All of these are also supported for the advanced users who are listening to this event. Then from a perspective of actioning on top of this intelligence, we provide capabilities for you to take these insights and act on them in real time, either through activations through channels and channel providers. Could be SMS, mobile app notifications, could be emails, could also be scripts that are provided for the call center agent or the physical store agent, right? It also could be used for providing recommendations, and these are next best offers or actions that need to be taken for specific individuals, not cohorts, not segments, but individuals. And therefore, these recommendations are available at the entire scale of your customer base in a manner that's live, right? That's also capable, that's also possible. Then a third interface that we support with respect to consumption is what we call as audience discovery. With that, let's actually get into a demonstration of how audience discovery works. So audience discovery is our application for helping campaign managers to look at the customer intelligence that's been mined from the data. So it's accessed just using any other browser that you have at your disposal. And it also features a very straightforward, easy to use search interface. Much like Microsoft Bing, you could just search using natural language, and it bubbles up insights or behaviors that the Cadence engine has been able to mine from the data. So in this case, the behavior pattern that I'm interested in is the set of extravagant users. And these are users who've essentially spent more than 80% of their total savings, as an example. So this could be, for instance, the kind of behavioral pattern that a campaign manager in a bank might be looking at their customer base. So you could also search for other kinds of behavioral patterns which are interesting from the data. So in this case, like you see, the tool is suggesting bargain shoppers is something that's standing out as a pattern. The set of all female shoppers is something that seems like an interesting cohort. Frequent complainers, loyal customers, and so on and so forth. So I'm going to stick with my extravagant users for the purpose of this demo. So the moment you type this in and you search, it brings up the set of attributes that you're interested in for people who are looking at these kinds of behavioral patterns. So the total audience size in this case is just 559. So it's able to pick up needles in a haystack and bubble that up and look at associated behavior patterns. So of the set of users who are extravagantly spending from their savings, there is a breakdown of them and their usage patterns of the modes of payment itself. So in this case, debit cards turns out to be a standout behavioral pattern. And additionally, what are the kinds of items that they actually spend a lot of money on or do a lot of transactions on? Turns out food items is one of the biggest, followed by medical expenses, entertainment, and so on. And additionally, you could just drill down deeper and start to see additional patterns on top of each of those subsegments. And you can see for yourself how the audience size has changed, method of payments that have also changed. So here, for instance, for this cohort, which looks at food items, check-based payments are potentially stand out for some reason. You could also go back and start to look at additional behavioral patterns which are not obvious. So for instance, here, the people who are extravagant spenders are also the ones who are actually likely to have medium to high affinity, like close to 40% of their population is actually having medium to high affinity for travel, which could be an interesting attribute if you're looking at, for instance, selling a co-branded frequent flyer credit card. Likewise, home loan is an interesting attribute that comes out for this particular population base. And likewise, so on and so forth with respect to things like shopping affinity, gender. You could also additionally tweak this and change the selections and play around with it. But the best part is at the end of it, you have a mechanism to actually take this and export it out to your favorite tool. And that could then trigger a bunch of different campaigns around it based on emails, based on various other channels of interaction. So let's come back to what's the kind of value proposition that we've been able to drive with Cadence to some of our customers. So one of the flagship case studies that we have is to be able to drive contextual offers at the point of sale for every single transaction where the acquiring bank is also the issuing bank. So this is an example of an MNC bank where it has a lot of point of sale machines where it's also the acquiring bank. So the credit card or the debit card transaction or the wallet transaction that happens in these point of sale terminals gets captured by the bank. And internally, that message of the transaction is actually relayed to Cadence live in real time. As soon as that transaction lands on Cadence, there is the next best offer that needs to be provided to that particular user that goes out, along with the intelligence about where is the customer right now at that particular point in time. So for instance, if I'm the user and I have a credit card from a bank as an example, and I'm shopping at, let's say, Changi Terminal 3, and I'm using my credit card for a shopping transaction at Starbucks. So the transaction goes back into the Cadence platform live, and within Cadence, there is this behavioral profile about me that's been built up to say that I'm the user who typically likes coffee at this time of the day, every day, right, every weekday. And then additionally, it also uses the fact that I am at the airport, and the people at the airport are usually captive audiences. And it also knows the fact that at this time of the year, I typically like to buy some things related to the summer, right? So it starts to give me a suggestion for walking into a toy store, which is nearby, to get an inflatable swimming pool rink, as an example. So the fact that it could be something else related to the summer is also possible based on the behavioral patterns and transactions. But all of this is happening in real time, so that the message then goes out to the user, in this case, me, within 2 seconds of my transaction at Starbucks. And it encourages me with an SMS to go to the toy store, which is just right in the same terminal, and use my bank credit card within the next 15 minutes to get an extra 5% off, right? So, and this kind of a targeting is obviously something that's possible only if the customers are willingly opted in. So it's fully aware of privacy considerations. It also keeps track of opt-in and uses only the data that's been collected explicitly for this purpose to advertise back to the users. But the best part is the bank had seen a close to 20% uplift in the usage of their credit cards, and therefore they were actually able to drive a lot more traffic to their partner merchants. So that became a big success for the bank. The next example here is from an oil and gas company. This is one of Asia's largest oil and gas companies. What we have managed to do here is not only process in real time thousands of transactions per second, and these are payment transactions made by people like you and me shopping for fuel at the petrol pump. Additionally, there is also sensor data that comes in from what's called as retail outlet automation technology. And these are essentially sensors which are capturing the lift of a nozzle, the dispensing of the fuel, and the lights, right? So both these data sets are integrated in real time to service the customer, to be able to provide them service assurance that whatever method of payment that they choose is available to them, could be digital, could be cash, could be wallets, to drive loyalty, to drive the fact that these are frequent transactions that have happened with me as an enterprise. So let's reward the customer for it. But additionally, the same data set in real time is also used as a way to operationally monitor the entire asset base of this particular oil and gas company. So this monitoring dashboard became pretty much the de facto standard for all of the field officers in the oil and gas company to have the latest status of every one of their equipments under their control. So that became extremely powerful for them to also start to issue notification service calls so that you don't have to wait for 3 days or 4 days for somebody to file a complaint, whereas this just happens automatically because of the automation, because of the AI that's inside the platform. So both of these are examples that were driven from a Cadence perspective. So moving on to the third example of how we used Cadence, this is the context of lending to SME businesses, that's small and medium enterprise businesses. So the bank is looking at lending to this particular sector using data sets or data points which have not been traditionally considered in this kind of a lending landscape. So here we're looking at existing usage of previous loans that the SME clients might have taken up. So the bank uses that loan usage data. That data is then fed into the Cadence pipelines. The pipelines run on top of Microsoft ML Server and come back with a credit score. The score indicates whether to proceed with that particular credit decisioning or not. And wherever it's not able to make up its mind, it comes up with questions that need to be asked further in order to clarify certain situations or certain metrics. So this entire flow typically happens within 1 minute, so that the entire credit decisioning process, including due diligence, happens within 1 hour. And that's been now responsible for driving close to $56 million of business on a monthly basis for this bank, and that's new business we're talking about. This has not been traditionally tapped into. So this business volume has just continued to increase, and the pipelines that we've built up has been able to scale to maintain that particular response times that we've been able to give so far. Now let's move on to the next set of applications that we have with respect to AI and machine learning applied at large scale. The first example I want to pick up is a very large solar panel manufacturer, one of India's biggest. And here the problem statement is that the current assembly line mechanism of manufacturing the solar panels has a lot of manual components involved, specifically from a perspective of quality control. So there are agents who are looking at the fully formed panel images, and these are images being taken by a method called as electroluminescence. And the electroluminescence images are looked at by the quality checkers, and they manually look for presence of defects on top of the panels. The examples of defects could be things like cracks in the panel, could be examples of malformation when the cells in the panels are put together. And there are a few such examples more. And these are manually tagged. And once the tagging happens, then there is a robotic arm which takes these panels of different kinds and sorts them into different bins. So as an example, cracks which are minute are not going to really affect the usage of those panels in, for instance, the residential sector, but those panels are not usable in a commercial grade deployment of the solar technology. So that's one example. So those are two different bins, commercial and residential. And there could also be, of course, the defect bin, which means the panels cannot be used for any purpose at all. So this entire process was manual, which meant that there were 3 shifts of 8 people monitoring these assembly lines, 24/7, ×360. So they were. It was an extremely intensive manual operation. So one of the first things that we were able to do was to demonstrate that from the panel images themselves, which are the electroluminescence images we were talking about, we could go to an AI model which could look at detecting the presence of a defect. So detecting whether a defect exists or doesn't exist, and that defect detection itself could be achieved with even better accuracy rates than the human operators themselves. So that was the first demonstration that we did. The second thing that we did was, in addition to being able to say that there is a defect, we could additionally train a new model, and that model was able to classify the nature of the defect as well. So put in conjunction together, what we were able to demonstrate with respect to this particular pipeline was that with close to 99.4% accuracy, we were able to detect the defect that occurs in a specific assembly line for each panel, and additionally also detect the class of the defect so that they could take additional corrective actions in a way that's automated. So this got down the entire response time from panel assembly through the sorting of the panel into good or bad to less than 1 second. And that became extremely beneficial to ramp up productivity and efficiency of the factory floor as well. So the 3-year return on investment from a perspective of savings was close to 50x. So what this meant was that they could actually retrain the people who were involved in just merely looking at defect or not kind of quality checks into looking at root cause of why these defects are actually happening. So for instance, if it's as a result of panel formation using the individual cells, maybe there are configurations in the machines themselves that need to be addressed so that the formation is a lot more smoother, as an example. So this was a live implementation done in the factory floor, where the model building and model training actually happened on the Azure cloud, and the model was then deployed using IoT Edge, one of the PaaS services that Microsoft provides. The next example I want to bring up is an example that's going to be commonplace in most industrial workplace settings. So this is the problem statement of how do you ensure operator safety and safety of equipment, safety of the people that's operating these equipment. So the problem statement here is the fact that we're talking about an assembly line with people operating equipments, but in many cases, these are humans after all, and they do have behavioral patterns which are likely to cause certain forms of accidents. Like for instance, being distracted, either due to a conversation with your colleagues, or you might get or the operator might get a call on his cell phone, in which case he has to quickly attend to it, or it could be other forms of distraction. And believe it or not, in many cases, it could just be the case that somebody is really overworked with fatigue and ends up dozing at the assembly line, right? And these could happen over small windows, let's say for 30 seconds. Sometimes it's 5 minutes if it's a seated kind of position. And we've seen this happen across different kinds of factory settings. So what we were able to build here is a model that alerts whenever these kinds of safety violations happen. So we're able to pick up on the fact that an operator who's supposed to be at a particular equipment station is not present, so the operator is missing, or the operator is distracted. Distraction could be fleeting, could be just for 2 seconds, could be for a minute, could be for 5 minutes. And the distraction could be in the form of somebody not looking at their machine. Like for instance, me looking at my laptop always is the standard mode in which the manufacturing assembly line is working. But if I'm distracted and I'm looking upwards or I'm looking to the side, the distraction model actually captures this and alerts the shop floor manager and says that this particular operator is distracted for this period of time, and that means that there is a safety violation. Additionally, it could also be sleeping, as an example. And sleeping, believe it or not, is actually a very, very complex problem to tackle, especially when you don't know, just based on movements alone, whether the person is really intensely concentrating or are they really dozing at the job. So long story short, we've got the model itself built out as a series of distraction detection modules or sub-models, basically. And those were then applied on video data. And this was video data captured using standard network video recorders, which are typically available in these kinds of settings, and then these distraction instances themselves were stored in a database for the shop floor manager to then take some action. The third example is from a perspective of automotive. So here we're talking about telematics data coming in from light commercial vehicles. So these are trucks, for instance. So these telematics data typically are capturing the metrics like velocity, speed, latitude, longitude, locations, turning radius, accelerometer readings, etc. Right? And this is telematics data that's being captured at a frequency of once every 10 seconds, ranging all the way to once every minute. And the data set is then married together with warranty data. And the problem statement that we're looking to solve here is, can I reduce the overall expenditure of my vehicles under the warranty period? And the reason why this is an important problem statement to solve for in the world of automotives is that any expenditure that's actually incurred in this period is cost to the company, which is the OEM, but the customer itself doesn't actually pay for it, right? Because it's within the warranty period coverage. And in many cases, especially for these industrial customers, the warranty period could be extended for many years, or could be taken afresh for a refurbished kind of a product as well. So we'll have to take into account what is the nature of the vehicle, what is the nature of the assembly of the different parts, and put it all together to form a holistic picture about cost management here. So one of the first things that we were able to do was to come up with what's called as failure mode prediction. So anybody who's worked on preventive maintenance or predictive maintenance kinds of use cases, you will recognize that being able to characterize the failure modes itself is a important problem to solve. And getting to that classification allows you to formulate what needs to happen with respect to machine learning, or with respect to rules, with respect to technology itself as downstream activities. So the first step is, like I said, failure mode classification. Once we did the classification, we were then able to build a prediction model on top of it. And using this, we were able to power two different sets of consumers. One is the monitoring dashboard itself. The dashboard was responsible for giving an accurate picture of what's happening with respect to my entire fleet of trucks that have gone into the market. The second part of it is actually the cost management pipeline itself from a warranty standpoint. So here I would like to show you some visuals as well as to what we were able to achieve as part of this outcome. So one of the first things that we noticed was that across the different states or provinces of this country, the warranty expenditure varied based on which state you were from. And this, if you see, for instance, the first two states on the left, as well as some of the states towards the right corner, they had far higher warranty expenditure. And that's something that stood out as a pattern. And then we started to break down the different telematics metrics in terms of speed, kilometer readings, etc., etc. But we eventually came down to analysis of these metrics with respect to the distance driven by each of these trucks in relation to the time to fail. And time to fail here was based on the logging of the complaint itself by the customer when they come in for this warranty servicing, and then the expenditure incurred by the OEM. And then we applied clustering, which is one of the unsupervised techniques, to come up with the optimum distribution of the clusters themselves. So at this stage, we were still exploring what's the nature of the behavior of these trucks, and can I form a pattern based on this behavior. So it turns out that the optimum number of clusters to actually explain this behavior was 4. And interestingly, if you see, one of the clusters that really stands out is cluster number 3. So once we dove deeper into what the set of trucks were in cluster 3, we found that there were actually correlated parts that were failing. So these were parts which were related to each other in some form or shape in respect to the functioning of certain parts of the truck, right? Certain movements in the truck. And these parts were having failure patterns in such a way that if one particular part failed, there was another failure that also happened either concurrently or happened after a period of time. So the kind of expenditures that was incurred for these trucks was from a perspective of getting the customer back in for the second service visit in order to replace this other part as well. Whereas the insights that were actually coming from here now allowed the OEM, the manufacturer, to say that in one sitting, let's just tear down the entire truck, replace all these parts which are correlated, and put it back up again, so that the cost of actually tearing down and putting it back again, or the cost of asking the customer to come back in one more time, all of those goes away. And so that became a significant cost savings for this particular manufacturer. With that, I've come to the end of my talk, showcasing what are different ways in which AI can be operationalized across different types of industries. So we've seen examples from the world of fashion, banking, payments. We're talking about examples from the world of telecom, retail, and some of the more recent examples are from traditional industries, which are factory floor settings, manufacturing establishments, and even assets which are decentralized, like petrol pumps, assets which are on the roads, like trucks. So across a variety of different types of use cases, AI can play a very powerful role. And the way that we manage to bring about these kinds of business benefits for our customers invariably starts with an ideation session. So we call this the innovation workshop. Typically, it's a 2-day workshop that we run for our customers. And this workshop forms the basis for envisioning new forms of AI, new uses of AI for your problem statements, and then powering your business initiatives using applications of AI. So I would encourage you to look up more details about this in the PDF that's actually present in the resources section. So you can look up for the title Innovate with the Data Team in Azure. Additionally, if you're interested to sign up, the URL is right here. It's cadence.ai/innovate. We've hosted the URL on our platform offerings with Cadence. In the URL, you'll see basic information that's been asked about your problem statement and your setting, your industry. So share as much as you can, and then we'll definitely get back to you and schedule an innovation workshop at your premises with your problem statement, so that we are able to drive your use of AI on Microsoft Azure Cloud. Thank you very much for listening patiently. We now have the question and answer session that's open for the next 15 minutes. You could ask questions in the chat window, and this will be applicable and answerable for all of us that spoke today, Microsoft Databricks and the data team as well. Thank you again.